So, for today's video, I'm going to go through a few exercises related to our current topic of algebra. What I'd like you to do is I'd like you to put this title in your book and then put all of the exercises underneath that title so I can clearly see when I have a look at your book where this homework is. What I'll do is I'll let you know the exercise number. Then I'd like you to pause the video and I'd like you to look up the exercise yourself and I'd like you to try it yourself. So don't just read it through and then come back to the video and expect me to solve it for you. You'll get a lot more out of the video if you try it yourself first and then you come back to me and then see how I do it, and then it will give you an opportunity either, if you could do it fine yourself, to check your answer, or if you were having trouble, to see how to do it. So then 3, come back to the video, check and correct. Check or correct. So the first exercise I'm going to be doing is on page 49. Exercise 134. So please now pause the video, look it up, try it, and then come back to me. So I assume now you've paused the video. When we have a text exercise like this or a word problem, I like to break it down into two different parts. First of all, what do we know? And secondly, what do we want to find out? So let's see if we can answer our first question in blue. So it's about the entrance to a swimming pool, and adults cost €, and children pay only a third of what the adults pay. So I can do this in terms of E. I also know then that children cost E/3 euros. So that's what I already know. What do we want to find out? Number 2 is actually just the second sentence or question in this exercise. What's the daily income for X adults and Y children? So the total income will be my income for the adults plus my income for the children. And let's call this T, either for total income or for Tageseinnahmen, we could also say. So the income for the adults would be the number of adults that we have multiplied by the price each adult pays. So I have X adults, and each of those adults pays E euros. So the total income here will be X times E. The number of people times the amount each person pays. They pay that amount X times, because there are X of them. And the same for the children. So we have Y children times by E/3. And like I said in lessons, when we have fractions like this, it's always best to put both of the whole numbers on the numerator, on the top of the fraction, and put them over the same denominator, so that then we can see what's supposed to be on the top and what's supposed to be on the bottom. So this is, you could also equally write Y times E/3. And as long as you just divide by 3 once in your expression, it's exactly the same thing. So hopefully you came out with an expression similar to this in your solution. So let's move on to the next question. Still on page 49, I'd like to do the next exercise, 135. Please pause the video and see if you can do this one. So, I assume that you've paused the video. We need to look at the life insurance costs for men and women. So first of all, what do we know? What do we know? We know that women, so a woman under 40 pays €, and a man under 40 pays 20% more. Now, I chose this exercise specifically because I know that some of you shy away from percentages, let's say. The easiest way to show percentage increase is just to say that that's 1.2 times F euros. And I'll show you how this works. So a man would pay F euros plus 20% of F. So that's F plus 20 over 100 times F, and make sure that F stays on the top there. If I bring this over the same common denominator, that's 100F plus 20F over 100, which is 120F over 100, which then, if I cancel, you can see that that's 12F over 10, which is 1.2F. So that's how percentage increase works. I can just use a multiplying factor here to show that. Secondly, what do we want to find out? Well, we need a formula for the total cost for a husband and wife that have decided to take out this insurance policy. So let's call it maybe C for total cost. And obviously the married couple will have one man and one woman. So for the woman they'll pay F euros. For the man they'll pay 1.2 times F euros, which of course we can simplify because this is 1F plus 1.2F, that's 2.2F. So 2.2 times F is the total cost that they will pay. And that's then part A done. Part B wants the total income, so let's call that T, that it would get for 390 men and 721 women. So their total income would be the number of people who've chosen each policy multiplied by the cost of each policy. So if we do the women first, just as we did up here, we have 721 women, and they each pay F euros, so times F, plus 390 men, multiplied by 1.2 F. And of course, we can simplify this. 721 F plus 390 times 1.2 is 468 F, plus the 721 F is a grand total of 1,189 times F, which is obviously the price they decide to charge for the women's policy. So if you want to write your final answer neatly, that's the bottom line. Okay, so hopefully those two are now okay. Let's move on to another one. So, this time let's move on to page 50, and I want to keep with our percentages theme. Sorry, not 50, 52. So first of all, I'd like to have a go at exercise 150. Pause it, read through, see what you can do yourself, and then come back to the video. So, let's start with A first. We have 32 children in our class. This is what we know. And we know 25% of them are boys. And our first job is just to find out how many girls and boys there are in the class. So 25% of 32. We can translate this mathematically to say 25 divided by 100 of, as I've mentioned before, is normally translatable into mathematics as multiplied by, then 32. And of course this fraction can be cancelled. 25 goes into itself once, and it goes into 100 4 times. So actually we're just looking at 32 divided by 4, which is 8. So we have 8 boys. And so that we complete the question, we also need to say how many girls there are. So this means that we must have 24 girls to make up the 32 children in the class. So, the second part of the question, M% of girls and B% of boys leave the class in the break time. How many children are left over? So, we need something to say how many children are left over. Let's say, let's define the variable C as children in the class or in the classroom at break. So this is going to be C is equal to our 32 children, take away all of those who leave the class. So M% of the girls, M% of the girls, which are 24 girls, and B% of the boys, 8 boys. And of course we can cancel these as well if we want to. I'm going to cancel each of them by 4. So 4 goes into 24 6 times, and into 100 25 times, into 8 twice, into 100 again 25 times. So I have this same common denominator here, and I can then simplify this to be 32 minus 6m over 25 minus 2b over 25. And I can bring these two over a common denominator. But what I would need to do first is to take out the negative symbol as a common factor. So this subtraction symbol here, the minus. So if I do 32 minus, in brackets, 6m plus 2b over 25, then you'll notice that if I multiply out this bracket, I'll get minus 6m and minus 2b again. So you just need to be careful here when taking out the minus symbol. And this then is my final answer. And of course I could multiply 32 by 25 and bring this into the whole fraction as well if I wanted to, but I don't think that's necessary here. Okay, so in the next video I'm going to move on to a couple of different questions. The first one of which will again be on page 52. It will be exercise 151. So take a look at that, and I'll start the next video with this question.